This exam question looks like 3 Helm commands: add a repository, render a template, install a release. And it hands you a comforting line: the Argo CD CRDs have already been pre-installed in the cluster. In this lab, that line is false, on purpose. And what happens next teaches you exactly what crds.install equals false really means. Here is the question. Add the official Argo CD Helm repository to the cluster under the name Argo. The URL is given in the question. You never have to memorize repository links.
The Argo CD CRDs, it says, have already been pre-installed. Generate a Helm template for release Argo CD,
chart version 7.7.3 in the Argo CD namespace.
Save it to argohelm.yaml and configure the chart to not install the CRDs.
Then install the release with the same name, version, and namespace, again without CRDs. And one thing you do not have to do: configure access to the Argo CD server UI. 3 commands, 1 premise. 3 Helm verbs do the work. Helm repo add registers where charts come from, under a name you choose. Helm template renders the chart into plain YAML in your machine. Nothing touches the cluster, which is why the question can ask you to save the output to a file. Helm install submits that same render to the cluster as a managed release. A flag that ties them together is set_crds.install equals false. The Argo CD chart bundles the Argo CD custom resource definitions, and when a question says the CRDs are managed separately, your job is to keep the chart's hands off them, in the template and in the install. Keep the 2 commands identical apart from the verb. If they drift, the file you saved describes a different system than the one you deployed. Step 1. Helm repo add Argo. Then the URL from the question. Helm fetches the repository index immediately, so a mistyped URL fails right here instead of at install time. Helm repo list confirms the repository is registered under exactly the name the question asked for, Argo. Step 2. The template. Release name Argo CD. Chart Argo/Argo CD. Version 7.7.3 pinned exactly. Namespace Argo CD CRDs.install set to false. And the whole thing redirected into argohelm.yaml. The command prints nothing because the entire render went into the file. And it is substantial, over 3,000 lines of YAML. Here is the check that proves the flag worked. Grep the file for kind custom resource definition. 0. This chart normally ships 3 CRDs. With the flag set, the render contains none of them. Step 3 is the same command with the verb swapped. Helm install, same release name, same chart, same version, same namespace, same crds.install false. Helm prints the release nets, and Helm ls in the Argo CD namespace shows release Argo CD, revision 1, status deployed, chart Argo CD 7.7.3, appVersion 2.13.0. As far as Helm is concerned, the job is done. The cluster is about to disagree. Give the pods a moment and look again. Redis and Dex are up, but the server and the application set controller are already in a crash loop, and the application controller never goes ready. Everything that watches Argo CD resources is failing. Pull the logs from the server, and the last line says exactly why. Level fatal. The server could not find the requested resource. That is a component asking the API server for a resource type that does not exist. We told the chart not to install the CRDs because the question said they were pre-installed. They are not. The premise was false, and Helm had no way to know. Confirm the diagnosis in 2 seconds. kubectl get CRD, grep argo proj, nothing. So we install the CRDs ourselves, but pin to the right version, because CRDs and controllers drift apart across releases. The chart's appVersion tells you which Argo CD this chart deploys. Helm show chart says 7.7.3, ships version 2.13.0. Apply the 3 CRD manifests from the Argo CD repository at exactly that tag: applications, application sets, and app projects. The crash-looped pods would eventually recover on their own as the back-off retries. But do not sit and wait in an exam. One rollout restart of the workloads in the namespace brings fresh pods up immediately. And this time, every informer finds its CRDs. A minute later, the whole namespace is running and ready. That is the full question. Repository added as Argo.
Template saved with 0 CRDs in it. Release installed at 7.7.3. And a healthy Argo CD.
And notice what the fix was not. We never touched the Helm release. The release was correct. The environment broke the promise. A few traps. The repository URL and the chart version are printed in the question. Copy them, pin -- version exactly, and never guess. Template and install must carry identical values. Same namespace, same set CRDs install equals false. Only the verb changes. When a question states a premise like CRDs are pre-installed, verify it. It costs 2 seconds. kubernetes get CRD, grep Argo proj,
and learn the signature. A controller crash looping with the server could not find the requested resource
means a missing CRD, and the chart's appVersion tells you exactly which CRD version to apply. To recap, Helm repo add Argo, Helm template, Helm install, all pinned to chart 7.7.3 with crds.install false, exactly as the question specified. Helm said deployed, but the pods said otherwise because the pre-installed CRDs were a false premise. The logs named the failure, the chart's appVersion named the fix, and after applying the version 2.13.0 CRDs and a rollout restart, everything went green. Green Helm status is not a healthy release. Always end on the pods. Subscribe, and the full write-up is on dev.to.